Okay, this section, been talking about it for a while, is where we're going to start working with radicals and where we've got negative numbers underneath when we have a radical, which is impossible because when you square a negative, it winds up being a positive. So when we're looking at these, we're going to be talking about real numbers and imaginary numbers. Okay, so if you remember first semester, when we were classifying things, and yes, you're writing this, okay, on your notes. Rational numbers were numbers that were positive and negative numbers that could be represented as a ratio. And ratio would be like a fraction. So example could be like 4/8, or just the number 8, because I can write it as a fraction as 8/1. Okay. Irrational numbers are numbers that don't terminate. Okay, so example would be like the square root of 5. So if you actually took the square root of 5 and put it into your calculator, you're going to get a repeating decimal. Okay, pi is an irrational number because it never terminates. Okay, 3.14 and it keeps on going. Okay, imaginary numbers are represented by the letter I. Okay, for imaginary. Anytime you take a square root of a negative number, this is considered an imaginary number. Okay. Now, the other word that comes together with this that you're going to add on is that these two, if we were to do another graph thing and put a circle going all the way around, okay, I'm not going to do that. I'm just going to point to these two. Okay, if we were to encompass all of these, we call these complex numbers. Okay. Obviously, some are simple, some are more complex, like the imaginary numbers. Okay. All right, so pause if you need to write these so we know the difference between the two. Okay, starting on the first one, so problems 1 and 2. Okay, when we're simplifying these, I know that the square root of 4 is just going to be 2. Okay, but we've got a negative involved in that. So if you go back to where we wrote the imaginary number, anytime you have the square root of a negative number, okay, and they just represented it by a -1. That was represented by an I. Okay, so when we take this -1 out, it becomes an I. Okay, so if we were to simplify this one, okay, this is really, if we separate it, it's a -1 times 4. Okay, well, we know that 4 is a perfect square because it's 2 times 2, right? So that's going to come out. Okay, well, just like this one where we had a -1, the -1 is actually going to come out as well and be represented by I. Okay, so the square root of a -4 is going to simplify down to 2, okay, from that, and I. Okay, so this is our answer for that. Okay, so now for number 2. Okay, if I were to break this apart, this is really a -1 times 3. Okay, well, 3 doesn't have any pairs that come out, so it would stay in there. But because this is under the radical, this is going to come out as I. Okay, so -1 underneath the radical is represented by I, and then you're going to leave 3 on the side. Okay, so really the only thing that's changing on this is, to start with, until we get some multiples of the i's, there's going to be a new rule for that. Okay, so trying it on to the next one. Okay, so -12, got a negative in there, so I'm going to represent this. Okay, I would have a -1 underneath, right? Okay, coming from that negative, that's right there. But now I would break down 12. Okay, so I find out what those squares are. So I could go 4, 3, or you could do 2, 6. Okay, 4 breaks down into 2, 2. So I have a pair. Plus I have the I that needs to come out. Okay, so I'm going to have 2I. Okay, and then left underneath it didn't have a pair is the 3. So hopefully you're catching on to this. It's pretty simple. Okay, so one more rule that I need you to write, and this is in regards to making sure when we write complex numbers, and the reason why we have complex numbers is because you might have a real number and then you might have an imaginary number. It's kind of like when you have 2x plus 3. Okay, this is similar. 3 is going to be your real number, And then we don't know what 2x is going to be, so that would be your other number. So when we write these, you have real numbers and imaginary numbers. They have to go in that order, okay? So when we start to have more than just one number like we just had on those last three that we did, the proper notation is to write the number that does not have an I first, okay? So that would be like 3, okay? And then you would write whatever had the imaginary number. It could still have a pi in it. It could have simplified down like that first one that simplified down for us, okay? So the order of proper notation that you write it is always the imaginary number is the next one, okay, is the second one. Okay, so examples of this, and this still relates to this, okay? Any number can be written as a complex number. Okay, so complex numbers are real numbers and imaginary numbers. So a real number, so we can write the number 4 as 4 plus 0i, meaning there is no imaginary number, but we can still write it as such, okay, representing complex numbers. Okay, this one here, I can write 3i as a complex number, okay? I don't have the real number, okay, so there's 0, but then I also have to represent the I as your second one, okay? So this is just rewriting these as complex numbers, okay? One with a real number and one with the imaginary number. Okay, so now we're diving into where we're gonna have the real numbers and the complex numbers, okay? So first parentheses, there's nothing to distribute or to change because you can't combine them. But in the second parentheses, so pause if you need to write this, we're distributing the negative to each one of those. Okay, so the first one comes down, it's going to stay as 3 minus 4i. But when I distribute the negative to the 4, it's going to change to a negative 4. And when I distribute the negative to the 2i, it's going to be a negative 2i. Okay, so now we're just going to make sure we write it as a complex number, okay, in the proper order, okay, in combining like terms. So I had 3 and a negative 4, which would give me a negative 1, right? We write the real number first. Okay, and then we combine the imaginary number. Okay, so we have a negative 4 and a negative 2, so signs the same, so it'd be a negative 6i. Okay, not squared, because you're not multiplying, you're just looking for the like terms to combine what's in front. Okay, and it's written in the form that it's supposed to be in, with the real number, and then your imaginary number second. Okay, order will matter. Out of order, you will not get it right. Okay, so make sure you start writing it properly. Okay, next problem. Okay, so now we're breaking these down, okay, just like we did at the very beginning. Okay, so if I were to break down a negative 12, I would break that down as a negative 1, which we had this as your third example. Okay, I have a negative 1 and I multiply it times 12. So we know that this is going to come out as our I, but now I need to break down my 12. Okay, which if you flash back to that first page that we did, this wound up being 2i rad 3, right? Because we broke down 12 into 4 and 3. 4 was a perfect square, okay, which brought the 2 out. Okay, so now we're going to do that with this one as well. Okay, so you're going to have a negative 1 times 7. So I know this is going to come out as an I, but now I've got to break down 27, which is 9 times 3. 3 times 3, doesn't matter which pair you choose. You can choose the 2 on the right or these 2 down here. Okay, so I know there's a pair of those, so that's going to come out. So I have a 3 that comes out and the I that comes out. So I have plus 3i. Okay, and then that's minus, right? Okay, and now you write what's left, which I think was left was a 3. Okay, so if these are like terms, which means that this part is the same, okay, and then the I that's on the outside is the same, then you can combine those, okay. So combining these two, we're just adding the number that's in front. We don't do anything with the I. It's kind of like looking at it as the like term. They both have imaginary numbers, okay. So this one, if you combine it, is 5i. Okay, you don't have to write those as complex numbers. It's just the ones that have multiple things that make sure you write them in the proper order. Okay. All right, I need you to write this down. Pause the video if you need to. Okay, so what we're looking for, if you are looking at the pattern of the difference between a square root and a square, there's something that we do. Okay, so if I were to replace these, okay, we need to figure out what this number would be right here. Okay, so what if I were to replace this with 25? Okay, if I took the square root of 25, right, I would get 5. So I'm just going to write this off to the side. You don't need to write this. We're just trying to figure out what the question mark is. Okay, so you can get this. So if I replace this with actual numbers, okay, we would say that this is 5. Okay, well now replacing, okay, so now if I take the number that is here and I square it, right? So if I take this number here and I square it, okay, what would I get here? Okay, so the question is, what we get here, right, is really what's underneath the radical we get. Okay, so if you follow that pattern there, then that means that this number right here should be a -1 because it was what was underneath there. Okay, so anytime you see, which was what we started with, a -1, it comes out as I. Okay. If you wind up with an I that is being squared, okay, your answer is going to be a -1. Okay, so we're going to be changing this up a little bit because now we're not going to have just one I like we have on all these other ones. Okay. All right. So starting with this one. Okay. If I were to break down a -6, okay, this is going to be a -1 times 6. Okay, so, sorry, I paused the video because that's going to be good. So simplifying this down, we have a -1, okay, which we know what's going to happen with that. 6 does not have any numbers that would come out because that would just be 2 and 3, right? And so there's no pair, so we know that that's going to stay there. So the -1 comes out as I, and you still have rad 6. Okay. Now this is multiplication, not an addition problem. I'm just not going to put them together. I'm going to leave them separate. Okay. Okay. So if I leave that separate, then I can simplify this one down into a -1, right? Oops. Right that way. Let's go here. I can simplify this into a -1, and now we break down 20. So if I broke down 20, I can go 2 and 10, right? And then 2 and 5, so I would have a pair of 2's that would come out, plus the negative that would come out. Okay, so that's going to make it 2i, and then the number that is left over is going to be 5. Okay, so we're at this point where we're multiplying what's in the front, okay, and what's underneath the radical together. Okay, so if I distribute this to this, it's really I times 2i, so it's just like x's. It'd be like x times 2x. Okay, so this really would give me 2i squared, right? And then with the radical, so 6 times 5 would give me 30. Okay, so something different here. Okay, so if you go back to what we wrote on this previous page, anytime you have an I squared, it now changes to something else. It's not the square root. Okay, so anytime you have an I squared, you're going to convert that to a -1. Okay, so looking back here, this is now 2, and it's right next to it, so it means times. This is really 2 times a -1 now. Okay, so 2 times a -1 is now going to change the outside to a -2. Right? This changes. Okay, so we learned something with the -1 when it's under the radical, what it becomes. Okay, when it's outside of the radical, if it's squared, it converts to a -1. Okay, so a -1 times 2 gives you a -2. So -2 rad 30. Okay, so let's try this again. Okay, so number 8. So if I break down rad 10, okay, this would be a -1. Okay, Okay, and then if I broke down 10, it's 2 and 5, there are no pairs, so it's going to stay the same, right? If there's a negative underneath the radical, it comes out as an I. Okay, so I have I rad 10. Okay, so now we're going to multiply, and we're going to break down this other one, which we had at the very beginning. Okay, this is really a negative 1 times 4, and 4 is a perfect square, right? So that comes out, and that comes out. Okay, so that gives me 2i. There's no radical left. Okay, so combining those two, so 2 times I, okay, is going to be 2i squared. Okay, and then I didn't have another radical to multiply it with, so it's just going to stay as rad 10. Okay, nothing's going to be simplified. Okay, but we have an I squared, so that I squared turns to a negative 1. Okay, so a negative 1 times 2 is going to make that a negative 2 rad 10. Okay, so just basically every time you see an I to the second outside of the radical, okay, it's going to change to a negative 1, convert to a negative 1. Okay, a little bit more steps on this next one, so number 9. Okay, so we're going to be distributing, simplifying, and then combining like terms. Okay, so I'm going to distribute this to both of these. Okay, so a negative 9 times a negative 6, so negative times negative is a positive 54. Okay, and then I have I times I, which is going to make I squared, just like it would if there was an X. Okay, and then the negative 9 times negative 5, so a negative times negative again is going to give you a positive. 9 times 5 is 45. But this time I only had one I to distribute. Okay, so done with that one. Okay, we'll convert this in just a minute. Okay, so we're going to distribute this. Okay, so 9 times 4 is going to give you a positive 36. Okay, and then 9 times a negative 8 is going to give me a negative 72. And then we only had one I, so combine them. Okay, so we're looking for like terms. Okay, so there isn't another I squared, so we just need to convert this and switch this I squared to a negative 1. So a negative 1 times 54 is going to make it a negative 54. Okay, like terms here, we don't convert when it's just I, we're just going to combine the like terms. So you have 45 and a negative 72, the I stays there. Okay, so that's going to change to a negative 7 I. Okay, and then we have the plus 36. Okay, so now these two, because I changed this one, okay, to a real number now, okay, then I can combine those to finish it out. You might catch it at the beginning and go ahead and combine these, but if you didn't, then just double check your work before you finish it out. Say, oh wait, those two are still the same, okay? So I have a negative 54 and a positive 36. So you're not switching signs, there's no equals, okay, you're just combining them just like they are. So that means I'm going to subtract and take the sign of the larger number, so it's going to be a negative. And that gives me 18. And then this one didn't have another one to combine it with, so it stays the same. So remember, when you write this, okay, it's supposed to be the real number and then the imaginary number. So make sure you write them in the proper order. So that's your final answer. So negative 18 minus 27i. Okay, next one. Okay, now we have a little bit of a FOIL method going on where we have to distribute this one to the right, both of those, and then this one to the right as well, using our FOIL. Okay, so the first one, I'm going to distribute the 2. So 2 times negative 9 would give me a negative 18. Okay, then 2 times 4i is going to give me 8i. Not squared, just one of them. Okay, now I'm distributing my 7. So 7 times a negative 9, okay, is going to give me a negative 63. And again, I only had one I that got distributed. Okay. The last one, now I have 2 i's that are going to be distributed. So some of you will catch it right on and just go ahead and switch it. Others, you can leave it as I squared and then switch it later. Okay, so 7i times 4i is going to give me 28i squared. So that's what I was talking about. If you know that you see that there's 2 i's, you already know this is going to switch it to the opposite sign. Because this will be a negative 1 that now changes that positive 28 to a negative 28. So some of you will catch that early on. If not, write it out. Okay, so now we're combining our like terms. So I have a negative 18 and a negative 28. So the signs are the same, but I'm going to take the sign a larger number. And remember, we always write the real numbers first, okay, and the imaginary number second. So 18 and 28 is going to give you 46. Okay, and then we're combining our like terms for those ones, so the signs are different, right? So we would subtract and take the sign a larger number, so that means it's going to be a negative, and you would get 55i. So this one had the I squared there that you changed, and then you did have the two middle ones that you would leave as is. Okay, I believe this is our last one. Okay, so this is the same as the previous one, except the way they wrote it, they didn't write the parentheses twice. So this means that you're going to write this parentheses twice, so you can use the FOIL method to distribute it. Okay, so the top and the bottom mean the same thing. Okay, so distributing this, so a negative times a negative is going to be a positive 121. Okay, a negative times a negative again is going to be a positive 22i, and there was only one I. Okay, so we're done distributing that first one. Now we're distributing the second one to both of those in the right parentheses. Okay, so again, a negative times a negative is a positive 22i again. Okay, and then the last one, negative times a negative is a positive. 2 times 2 is 4, but I'm going to have I squared, so I don't want a positive 4, I'm going to change it to a negative 4. So again, if you don't know where that just came from, okay, that came from having a negative times negative is a positive 4I squared, and remember the I squared changes it to a negative 1. So a negative 1 times 4 changes it to a negative 4. So if you need to write that, write that. If you don't, hopefully you're just kind of catching the pattern that's happening here, okay? Okay, so combining our like terms, I got 121 and a negative 4, okay, which would give me 117. And then combining our two like terms, okay, so we're going to add, and we've got 22 and 22, which is going to be 44i. Okay. And then you are done. Okay, so you're going to raise your hand after you are done with notes and get to try it from the sub, and you will grade it first thing tomorrow. If not, by the end of class, unless you get it done. Lesson quiz tomorrow.